Moving into lesson 10. It's slope and y-intercept, a graphical analysis. So we're going to be looking at graphs of linear function still. This time we're going to calculate slope, which means we're just going to give it a number. And once again, we're going to find the y-intercept. Let's look at our learning objectives. We've got two learning objectives. First, we're going to learn how to find slope using the x and y intercepts. Next, we're going to learn how to find the slope of a line using two lattice points. And I'll tell you about lattice points in just a few minutes. We've got some must-knows here. First is slope. Well, there's four kinds of slopes, if you remember from the last lesson. That's increasing, decreasing, constant, and undefined. We'll use those words again. You need to know how to simplify a fraction. So this is going to take you back to pre-algebra. Hopefully you can do it. If not, I'll give you an example. You need to be able to find the y-intercept, just like we did in the last lesson. We're going to add the x-intercept, which is just like the y-intercept. The only difference is it's x-axis, thus the name. And a lattice point. Well, a lattice point is just the crosshairs or the intersections of grid lines on a coordinate plane. So slope, just as a refresher, the slope is the steepness of the line. This line here. Is this slope increasing, decreasing, constant, or undefined? I'll give you a moment to think about it, and I'll meet you at the next slide with the right answer. This slope is increasing, and this slope is decreasing because it's going down the way you would walk if you're walking the direction you read. So increasing slopes, the y values are increasing and they go up the direction you read. Constant slopes, well, they're just horizontal lines. They're flat. It's like walking across the room. If you walk across the room, you'll run into a wall. That wall is a vertical line, and that slope is undefined. So the slope here, it's decreasing. We've established that. Do you remember what the y-intercept is? That's where it crosses the y-axis. So just so we're clear, the y-intercept here is, it's 2. And the slope, just because for fun, it's decreasing. It's going down. Now, what's the x-intercept? Well, that's just where it crosses the x-axis. So you look at the x-axis, here's where it crosses. What number is that? If you said 1, that's correct. Good job. There's a smiley face because you did such a great job. So the y-intercept is 2. The x-intercept is 1. The other thing that we hadn't looked at in a while is simplifying or reducing fractions. So here's just a quick review. First, you want to find the greatest common factor between the top number and the bottom number. And then you want to divide both the numerator, the top number, and the denominator, the bottom number, by the GCL. And this simplifies the fraction. So with 4 over 10, the greatest common factor is 2. 4 divided by 2 is 2. 10 divided by 2 is 5. We check to see if that can be reduced any further. And if you use the GCF, it shouldn't be able to be reduced any further. If you picked a factor that wasn't the greatest common factor, not a big deal. Just keep going until it's reduced, or plug it in a calculator. So graphical analysis. This is just, don't let the word scare you because it's not a big deal at all. It's just more math jargon. But we're going to use the x-intercept and the y-intercept here to calculate slope. And if you have a good graph, this is really the easiest way to calculate slope. So to express this slope as a fraction, we need to determine the type of slope. So is it increasing, decreasing, 0 or undefined. And we need a y value, then you need an x value. It doesn't matter which one that you're going to start with. So pick a y value, pick an x value, and I'll meet you on the next slide. So now that we've got our x-intercept, which is -6, our y-intercept is 3, we're going to write it as a fraction, and the fraction is going to be y over 3. So this is, remember, that's rise over run. Always remember, because you're rising, over is your fraction, and run is horizontal. I don't know if that helps you, but it helps me. So we've got our fraction as 3 over 6. Now we need to reduce this fraction because we always want to simplify our fractions. So 3 is a prime number, so I know I'm going to divide 3 by 3, then I'm going to divide 6 by 3, and then think for a minute to see if you can figure out what the answer is going to be. If you got 1/2, you're correct. And it's a positive 1/2 because your line's going up. The top of the line tells us if our slope or the fraction here is positive or negative. Now let's look at a negative slope. This is going to work just the same way. You got to determine your top of slope. Is this increasing, decreasing, 0, or undefined? You need a y value, which we got here of 3. You need an x value, which we have here of 6. You're going to write it as a fraction, y over x, or rise over run, because you rise up on the y-axis and you run on the x-axis. And a fraction is a number over another number. You don't need that. That's a typo. Ignore that. So you should have gotten 3 over 6. And our fraction is a negative. We need to put our negative sign here. -1 or 2. Because if we draw our stick figure here and they're walking in the direction we read, it's decreasing. And decreasing means a negative slope. So far, so good. So once again, to find the slope of a line with using the y and x-intercepts, you just see where the y crosses the y-axis. It's got to be a lattice point, which is an integer. So it's got to cross it at an integer here and here. Write it as a fraction, y over x. So whatever your y number is, divide it by your x, and then reduce the fraction. So now we're going to lattice points, and this is just crosshairs. A couple of reasons for this. One is your line may cross something like this. That's not a lattice point. The other reason is it's just smart to have more ways to solve problems. It makes mathematics a lot easier. So to calculate slope using lattice points, you pick 2 points. I always like to pick my points as close together as possible. So I'll start here, and I'll keep going up this line. See, I'm going up. The red dots, me going up. I'm going up till I get to my next lattice point. One reason I like to do that, it skips the steps later with reducing fractions. Sometimes I mess up and I still have to reduce my fraction. It's not a big deal. Then you're going to find your vertical rate of change. So I always like to go up, then I go over, which is your horizontal rate of change or your horizontal change. And then you count lattice points. So here I went up 1, 2, which is like we got the 2. Then I went over 1, 2, 3, which explains the 3. These other little triangles here just shows it does not matter. See, you go up 1, 2, 1, 2, 3. It doesn't matter which lattice points you pick. you'll always get the right answer. Just remember when we're doing this, the line goes up here, your slope is positive. So increasing lines equals positive slope. Decreasing equals negative. Horizontal equals 0. And a vertical slope is undefined. I'll keep repeating that because repetition's the key to learning, and you're going to need to know that for the rest of your time as a math student. Points to calculate the slope of this line. And I always like to think, before I do anything, what type of slope is this? Is this positive, negative, 0, or undefined? And I know that's positive because it's going up, and I'm going to, for fun, draw my little stick figure here. They're walking uphill. They're getting tired. So pick any two lattice points. On the next slide, I'll show you the two I picked. So I picked these 2 points here, that blue one, that little red one. You can pick any other one that you want, it doesn't matter. If you want to pause the video to make your work like mine, that's fine too. Sometimes as a student learning something new, I find it, especially mathematically, I find it's easier for me to comprehend what's going on if I'm doing exactly what it is the teacher's doing. So I'm going to count up 1. That's 1. Now I'm going to change directions and I'm going to run. That's 1, 2. So that's 1 over 2. Now I already did this, right? I calculated, I found my vertical change. I went up 1. Then after you find your vertical change, you're going to find your horizontal change. We got 1 over 2. And we're counting the number of units, and the units are all these little lines here. Each one's a unit. One in this case over or up. And then you calculate the slope. So we went up 1 over 2. Remember our slope is y over x, but it's rise over run. And if there's one thing you remember from algebra, like 30 years from now, somebody says, man, what do you remember from algebra? Remember slope, that's rise over run. So my rise is how far up I'm moving on the y-axis or down. That's a 1. My run is 2. So I know my slope here is 1 over 2. And once again, it doesn't matter. Anywhere I pick on this line, it's 1 over 2. And sometimes when I'm learning new stuff mathematically, like I'll go ahead and do it multiple times. Just the more times you do a math problem or practice a math skill, the more ingrained it becomes. So your slope is 1/2. Now let's think about the b. Where's our y-intercept? So I'll look on the y-axis. Oh, here it is. What number is that? That's right. It's 3. So our slope is 1/2, and shortly it's always going to be written as m is equal to 1 over 2, b is equal to 3. Another example here. What I like to do is, I always like to start my math problems with doing the easy stuff first. So the first thing I'm going to do is figure out, is this slope, is it increasing, decreasing, is it 0, or is it undefined? And then I'm going to find where it crosses or touches or starts at the y-axis. Well, I'm drawing my stick figure. Well, she's walking uphill. So I know my slope is positive. And then where does this cross the y-axis? What number is that? That's right, that is -5. So we know our slope is positive because we're going uphill. And then Next is I'm going to pick two lattice points, which I did. Got one, two lattice points. I started here, and I just went up this my little line. Got a lattice point, got a lattice point. Ooh, blue dot, lattice point. Sometimes this is called the triangle method because we're drawing a triangle. So in this case, we drew a triangle that went up 2 units, then over 3. So we count the units, 1, 2, which is where we got the 2 there. We went over 1, 2, 3, which is where we got the 3. So now we want to write it as a fraction as y over 3 because it's rise over run, because that's slope, right? Rise over run is slope, or it tells us the steepness of the line using numbers. So go ahead and write your slope, and you should have written it as a positive 2 over 3. And once again, sometimes it's called the triangle method because you form a triangle. So here, just to recap, I picked 2 different lattice points. I went up 2 over 3, up 2 over 3. If this is a test, I would count. I would count 1, 2. Now count 1, 2, 3. 2 over 3. Let's look at another example. The next example, we're going to look at a negative slope. So here, and I already gave it away, the slope is negative because we're stick figures walking downhill. Easy to walk downhill, so working with negative numbers is easy. Next, you want to figure out, where does this cross the y-axis? What's my b? What number is that? If you said 5, you're correct. Next thing we want to do is pick 2 lattice points. I'm picking this one here. And then I'm going down my little line slowly. See that red line? Here we go to the blue dot. I'll put my next dot here, and I'm going to go down 1, 2, over 1, 2, 3. So I went 1, 2, 1, 2, 1, 2, 3. So this is 2 over 3. What's the difference with this one? That's right, it's negative 2 over 3. Last one was positive 2 over 3. My b is y. So on your practice, you'd want to write m is equal to negative 2 over 3. B is equal to 5. Let's look at another example because we're having so much fun here. So this line is going to work just like what we've done before. Is our slope increasing, decreasing, 0, or undefined? Well, I'll put my stick figure here. But they're walking the direction we read. They're not going up or down. So the number that means nothing is 0. So our slope is 0. Where does this cross the y-axis? What number is that? If you said 4, you're correct. So I know my slope is constant, which is 0. You know my slope is 4. If I pick 2 lattice points, well, I can't rise, so my rise is 0. And it doesn't matter how far I run. In this case, I ran 1, 2, 3, 4. 0 divided by 4 is just 0. So the slope, once again, the slope here is 0. And we're done with this one. We've got one more example to look at. We'll make this example 3. And then let's look at example 4. Example 4, I'm going to follow all the same steps before. So I'm going to look and determine my slope top. Is it positive, negative, 0, or undefined? But it's a vertical line. Now I know if I'm walking across this page, I'm going to hit a wall. If you hit a wall, that's undefined. Now, where's the b-intercept? So let's go to the y-axis. I'm drawing, using my little pen here, going all the way down. It doesn't touch it. It's parallel. This line, this graph, this relation, this undefined relation is parallel to my y-axis. So what does that mean? My b or y-intercept does not exist. And remember, you can, in this course, in most courses, you may get a crazy teacher or professor that doesn't want you to do D and E, but D and E typically means does not exist in a math course. So for this course, any course you take with me does not exist as perfect. Let's just think about this. We can rise as many points as we want. Here we rose 2, but we could rise farther, but we can't run, so we're not running. And you cannot divide by 0, because when you have an integer divided by a 0, a number divided by 0, that's always undefined. Because when you have nothing, you can't make any more groups out of nothing. So that's analyzing, that's graphical analysis here of linear functions. So just to recap. Okay, let's recap what we did here. We worked with slope. Slope is the steepness of a line. To express it numerically, we write it as rise over run, with y being your rise and your x values being your run. But if it's a fraction, you always got to reduce it. It's got to be simplified for it to be 100% correct. As a teacher, I never counted off, full points for that, but I've had teachers that would count the whole thing wrong. I never liked those teachers. I always liked the teachers that maybe took off a half a point or a point. So that's what I did as a teacher. The easiest way to calculate slope given a graph is your x and y intercepts. If they're at a lattice point. If they're not at a lattice point, pick any 2 lattice points. And the key here is to pick lattice points that are close together. Because if they are close together, you will not have to reduce a fraction. But it's not a big deal to reduce fractions. Lastly, just double check the graph when you're writing out your slope. Determine if the slope is increasing, because if it's increasing, the slope is positive. If it's decreasing, the slope is negative. If it's constant, the slope is 0. And if it's a vertical line, the slope is undefined. Once again, if you have any questions or need help, you're not alone. I'm here to help you.